Hello, good morning. I like to share some of my teaching experiences with you so that you may know better about micro teaching techniques. A 12th grade boy wanted a tutoring physics. I said, okay, I will look into the time, give the timings, and you can pay and join. He said, no, sir, I like to have a demo class. I told him, okay, I am not a student to give demo. I am a registered and certified and experienced faculty. If you want, I can give you an intro session for you to know about micro teaching. He said, yes, sir, definitely. He fixed up a time and came. So when he came, I told him to start with, let me know what you know in physics. You are in 12th grade. All the way you have been learning a lot in physics. He said, I don't remember much. I said, okay, you tell me the one which you remember the best. He said, Newton's laws. I asked him, okay, spell the Newton's laws. He told, I don't remember the first two, but I remember the third one. Okay, you spell the third one. He told me every action has equal and opposite reaction. Good. I asked him to give an example. He said, I don't know. Any one which comes to your mind. He thought for some time and told, I don't know. Okay, I told, I'll put the question in this way. You said every action has equal and opposite reaction. Is the action and reaction are on the same bodies or different bodies? He's told definitely on the same body. Are you sure? He said 100%, sir. I've been learning this for a long time. I told him, you're wrong. It is not on the same body, it is on different bodies. The boy was very embarrassed. Asked me how. I told him, let me explain with some examples. Rowing of a boat. When you row a boat, you push the water backward. That is the action. The reaction is on the boat, which takes the boat forward. So you should remember Newton's third law as every actional force has a reactional force. And again, they are opposite. So every actional force has equal and opposite reactional force. They are on different bodies. Your action is pushing the water backward, whereas the reaction is on the boat taking it forward. Another example I can give you. Recoiling of the gun. When you fire a gun, the bullet moves forward, pushing the gun backward. It's called recoiling of the gun. That's why in NCC training they will say you have to hold the butt on your chest muscle tightly. If you keep it loosely, it will go and hit your collarbone and your collarbone will break. So the action is on the bullet, which moves the bullet forward, whereas the reaction is on the gun, moving it backward. So again, the action and reaction are on different bodies. Since the mass of the bullet is very small, it goes with a greater velocity, and gun heavier, it is pushed with little velocity compared to the bullet backward. Still the momentum is conserved. When you add the momentum of the bullet, when you see the momentum of the bullet and the gun, it will be equal and opposite. Since the velocity, since the mass is less, the bullet velocity is more. Since the mass is greater with the gun, the velocity, recoiling velocity is less. I can give you another example, propulsion of a rocket. I asked the boy, what is the fuel you are using in the rocket? He said, charcoal. I said, no. It needs low calorific, it needs low ignition temperature and high calorific value. Fuel with high calorific value. They use liquid hydrogen. So when the liquid hydrogen is ignited, the fuel pushes downward in the atmosphere. That is the action. The opposite reaction is on the rocket, which is pushing the rocket upward. So hope now you have understood the Newton's third law. Every actional force has equal and opposite reaction force. The boy said, yes, now I have learned third law. Excellent. I'll join your class. Thank you.